Hi, welcome back to the repair of this Lenco A50. After our rather spectacular event of the last video, I had quite a bit of work to fix things. Almost the entire left channel was blown out. I immediately identified 7 blown transistors, as I explained in the last video, I think, including the both output stages. As I also said, I found in my stock still a used 2N3055, so I put those one in. Now I have, a bit of a mix of output transistors. The 2 ones were sitting in there when I got the amp. I don't think they were original, but at least they were in there and they're working. Then the MJ20955 is the one that I picked up in the local electronics shop, and I think that's a genuine one, because I believe the 2N3055s that I picked up there, that they were fake. And then the missing 2N3055, I replaced it with the used one from my stock. So it's not perfect, but I got the amp working. See, have a look at the scope. There they are, both channels working. Man, that took quite a bit of time, especially because, wait, what are all the transistors that were blown? So we had both outputs blown, both drivers, both transistors here in the current limiting circuit, and then there was another one, I believe it was the bias spreader, that was also blown. And then I started checking other components. Oh yeah, this resistor, there was one resistor here, the emitter resistor on this side of the driver, I think, was also blown. That overheated quite spectacularly in the last video. Also the balance pot burned up. So I replaced that one with a high quality wire wound. I think it's 25 turn balance pot. I also changed the balance pot on the other channel as well, out of precaution. Then I also found that this diode was also faulty, and I found it out by really measuring it in circuit. In reverse, it measured a voltage drop of 1.2. And it should be totally open, so that one was replaced as well. And then I tried to power up the amp, and it worked. But I had a very bad case of asymmetrical clipping. I can show you a picture on the screen here. On the left channel, the negative side of the waveform was clipping extremely early compared to the other channel and compared to the upper side of the waveform. So that definitely still was an issue, and that really took me hours to find. I did a lot of troubleshooting yesterday evening. I swapped out the transistors in the protection circuit, didn't solve it. I swapped the voltage amplifier with the voltage amplifier on the other side, so I swapped them. Didn't change a thing. I swapped the output transistors from the left channel to the right and from the right channel to the left. The issue stayed in the left channel. What else did I do? I measured all the resistors in circuit, but okay, they all measured fine. I was so desperate that I even started measuring these disc ceramic capacitors. They also measured fine. So I was about to give up when I decided to also swap out this diode. Now that one tested perfectly fine in and out of circuits, but when I swapped it, the issue was resolved. So I guess that diode has also broken down, but at a higher voltage, higher than your tester actually tests. And when you turn up the volume at a certain level, it breaks down. So that is... that was a big effort to get this power supply rebuilt, to get the amplifier rebuilt again. But now it's working. See, I can turn it all the way up. So this is, it's now 4 volts, so 4.3 on one side, 4.2 on the other channel. The channels are tracking quite well. Obviously, since it's a mix of output transistors in there, they will never be 100% exactly the same. But the more that you turn up the volume, the more they are aligned. So this is looking quite good, actually. So this is now 5.5 volt. Now this amp should go to 50 watt. It's rated at 40 watt. Both sides driven at 1 kilohertz into an 8 ohm load. I think I'm now putting 800 hertz. Let me set this to 1 kilohertz. And 50 watts, that should be then 20 volts RMS, because 20 times 20 is 400, divided by 8 is 50 watts. So we should start to see clipping at around 50 watts. I have already tested this and it worked, but let me bring you a bit closer into the screen of the oscilloscope. Okay, so I think I have the oscilloscope a lot better in shot here right now. Let me set the vertical here to 5 volts per radicule. That should be okay. No, and let's set it to 10 volts. Yeah. And let's turn up the volume. There we go. 2.8 volt, 5 volt, 10 volts, 14. This is 19.5 in both channels RMS. So that's very nice. And this is almost 50 watts. If I go higher, then you will see it starts clipping. So I did a more exact calculation yesterday and I could reach 55, almost 55 watts. So let's just say 50 watts into an 8 ohm load. That's very good. Okay, so meet my new distortion meter. I just picked it up and I'm using it as is. I only cleaned it, so it's not calibrated or anything. So I'm not 100% sure how accurate it is. It's not super accurate because I am feeding in an 800 hertz tone and it's detecting it as an 810 hertz tone. I do think it needs a bit of service, but at least it can give me an idea in how far are we in the ballpark with the distortion. So let me turn up the volume. Yeah, you cannot see this on screen, but I have a signal on the distortion analyzer is connected to the left channel on the output. I have a 1 volt signal at the moment going in. So let me set the scale here correctly. Let's see, because now I am at a scale of 100% distortion. Let's see how far we're at here with a 1 volt RMS signal on the output on the left channel. 3% scale, 1% scale. And we are at .4.5. You have to read now the... Yeah, I'm touching something here, I think. Yeah. Let me turn off my light. That's also going to help a bit, probably. Yeah, my LED light, my new LED bench light is causing a bit of interference. But we are here now at 0.4% of distortion. If I turn up the volume, that should go down. Let me just go to a signal of... I'm also going to change the scale of the scope here because I'm using my scope to check the signal level. Let's go to a 5 volt. Okay, so now I have a 7 volt signal coming out. Go to a higher scale. See, we are here now at... Let it stabilize. Now you have to read a lower. So 0.15%? Yeah. So this is 0.15% of distortion. And I think I need to slightly adjust this here. Look at that. 0.1%. Let's go a bit higher even. Let's go to this is an 18 volt signal that I have coming out now. So we're let's say almost at 40 watts. So I have to go a bit higher in the scale here. Look at that. Below 0.1% of distortion. That's beautiful. Not gonna leave it to run like this because my dummy load resistors are cooking rather well, but this is actually not too shabby, I think. Okay, let's finally try some music again and hope that it doesn't blow up again just like in the previous video. Now, for you it probably sounds like shit because it's through my tiny microphone and the speakers are also tiny, so but to me it actually sounds pretty okay for these speakers at least. Every time when you have had a device, an amp or a radio or whatever fail on you in such an spectacular manner, then even though you fix the issue, it's still a bit scary every time using it again, thinking that it might explode again. Maybe I can try to hold my microphone a bit closer to the speaker. Yeah, that's not too bad, I think. Now, the only thing I still need to do is putting the front plate on. I have cleaned all the knobs. They were in the ultrasonic. I cleaned the front plate as well, so maybe it's a good idea to do that next. And then the LEDs. Yeah, those still need to be fixed like they are now. I hate them. And it's because the way that these bulbs are mounted in here, they are really mounted straight towards the VU meter, so you get these nice round shapes or these nice spots of light with LEDs. And these bulbs, like I said, are very hard to replace. So I ordered some new LEDs for this, and we're gonna do this properly, but I don't have them in yet. So I don't know if that will still be for this video. But at least I can start here with the front panel now. So the front plate is back on, and honestly I'm really happy with how this looks. It cleaned up very nicely. All the knobs, they were put in the ultrasonic and cleaned decently with a toothbrush. All the ribs here, the front plate as well, and it cleaned up pretty well. So yeah, it doesn't look too bad. Now for the LEDs, that's a different story. Here you can see what I already did earlier, but I'm not happy with the result here. See if I put one in. Let me just show you how it looks. It doesn't look great. Here on the, so there you have 3 positions for 3 LEDs here, and they are really pointed straight at the VU meters. Here on the left position, I still have an original incandescent bulb in there. And on the middle, I don't have anything right now. And here on the right, I have one of these LEDs. Let me show you how it looks. Yeah, so see, you clearly see that this circle that it creates is smaller than this one. If I take it backwards, or if I maneuver it a bit, I can make it look slightly better, but yeah, that's too close. See, then you really have a spot. But it's still not great because it's really too focused on one point. The angle for these LEDs is really too narrow. And also the color doesn't match, but I don't think it's too bad, this color. Now, where do these 3 LEDs come from? These are warm white LEDs that I got on DigiKey. Let me see if I can find... Is this the packaging? Yeah, here they are. So these are... yeah, I can give you the part number. It's QBL8IW60D-WW. And they are white diffused LEDs. And I searched for LEDs on DigiKey which had a white angle, as wide as possible. And this was from the warm white, the widest that I could find. I think it's about 60 degrees, but it's clearly not enough. So yeah, I didn't really know what to do. So I just, out of curiosity, I went on AliExpress and I bought quite a bit of LEDs, because they were packaged in 50 and 100 each. These are 5mm straw hat LEDs, and these are 8mm straw hat LEDs, and they are both advertised as warm white, and they should have a much wider beam. They should be like 120 degrees wide, so much wider than these. So I created a sort of little circuit on a breadboard just to see how they look. Okay, so here we are. This is the warm white from DigiKey, and those two are the new ones that I got from AliExpress. Now, the construction of these AliExpress ones is clearly much cheaper than these ones. The leads, they are, much less sturdy, and the way that they are potted in the top here, it's also not fantastic, but okay. I just put it on with a dropping resistor here directly on my power supply, and let me show you what the result is here, because it's very interesting. Now, can I remove the auto exposure here? Yeah. So it's interesting in the sense that this one here, it's yellow. For me, it doesn't really look like warm white at all. These were sold as warm white, but this is like more golden, or this is just a yellow LED according to me. And then this one, I'm not sure if you can see it on camera as well, but this one is a bit more greenish, the middle one. And the original one, which I had from DigiKey, is a bit more pink in color. Now, I never really liked that color a lot. It's a bit too pink for me. And this one is also a bit ugly. It has a bit too much green in there. Now, I checked multiple from the back, because yeah, I thought maybe there is a difference between the different LEDs in the same bag, but they all are more or less the same. Yeah, so I didn't really know what to do, because these two, they seem incredibly ugly. Definitely, I didn't want to have this really yellow one, but I tried it anyway, and the result is interesting. Let me show you if I put it in the VU meter. it's actually not that bad as it looks over here. Okay, so here on the left we have the original incandescent bulb, and on the right we have the new 8mm LED. And you can see that there is a difference in color temperature, definitely. This is more yellow than this one. But I'm not sure if I dislike it. Now, if I look here on the screen of my phone, which I'm using for filming, it does look quite, yeah, very yellow on the screen. It's much less bad in real life. So I'm not sure if I actually dislike it, this one. And also the area that it's filling, it's better than the previous one, and it's similar, I think, to the incandescent bulb, even though the fall off is a bit more drastic. But if you compare it to the 5mm ones, yeah, I don't know. That one is probably more close to the light of the incandescent bulb, but I'm not sure actually what I like here. What I do know is that the 5mm ones that I got from AliExpress, I definitely don't want those, because let me show you how they look. Okay, the way that they fill the meter is quite nice if you poke them a bit further down the hole, but they are really, they look even more yellow, I think, than the big ones, because they have this green component in the light, which is pretty bad. So I definitely don't like that. Yeah, difficult decision, actually. See, if I put the ones from DigiKey here in there as again, in terms of color temperature, I think they are the closest, but it's still not a good match. I have to think a bit about what I do, maybe try some combinations here, and maybe I'm gonna fit 3 of these 8mm ones in here just to see how it would look. And yeah, not sure yet. Okay, so I got now 3 of these 8mm very yellow ones in there at the moment, and honestly it doesn't look too bad at all. The spread dissipation is quite okay. You have a bit of hot spotting, but that was also the case with the incandescent ones. It's just inherent to the position. The coloring is quite okay. I do believe that this one is here a bit brighter than that one, so I might have to wiggle a bit on the positioning here on this right one still, but I think I'm gonna go for this option. What I also did is I removed the original grommets. So these were the original grommets, and I put in some new ones which have a bit larger hole. And then with the pliers, I cut off here the rim on the edge of the LED, and that made the LED fit perfectly in this grommet. And I was then also able to push it all the way through, so that you can get a full angle of the LED. And it's actually not too bad. The only thing I now still need to do is put a bit of super glue on the LEDs so that they stay in position in the grommets, just like I put them, and then maybe also a drop of super glue between the grommet and the chassis so that the grommets also stay in place, and then hook it up to the power supply. But let me do that, and I think it will actually be okay with these very yellow LEDs. Interesting. Very interesting. Okay, so I finished my work on the LEDs here. See, it actually doesn't look too bad. I kind of like this result. It's a bit more yellow, as I already said, than the original bulbs. But I think it's still okay. It doesn't really look like an LED at first sight. If I turn off the power, they also immediately shut off, just like normal bulbs. So that's quite nice. I'm actually, yeah, very pleased with this result. It's not too bright either. and the evenness is very decent. So what I did is I used these 8mm LEDs. They are straw hat type LEDs, but I also roughed up the lens a bit with some steel wool to make them a bit like frosted. And that also helps a bit with the spreading out the light. Or looks quite okay. Now, how did I wire them in? That's a bit of an interesting thing. Let me explain. Because there are, in a system like this, or in any amplifier, there are typically two ways of wiring up these LEDs. First thing that you can do is you need a sort of DC, any DC power supply basically. Doesn't really matter if it is like 5 volts or 20 volts. You can need to put a dropping resistor between the in series with the LEDs anyway, so you can adjust your resistor depending on the voltage power supply that you take. So you need a DC voltage power supply. So what you can typically do, first option, is to use the regulated power supply, the secondary regulated power supply. What is quite important is that it's regulated and a stable voltage, and that it doesn't have any ripple, because that will make your LEDs flicker. That it doesn't sag with the power, not too much at least. So these things are quite important to make the LEDs look good. So that's why a candidate is the secondary voltage, which is used by the phono stage and the preamp stage. And these are generated over here. I think that's this pink line over here that I drew, yeah. On this amplifier, this is 14 volts, and it's exactly spot on 14 volts, and it's quite stable, so you could use that. That's what I tried first. It works. The big drawback on this, however, is that you have your filter capacitors, which are on this, which filter the power supply for these voltages. And the problem with that is when you turn off the power, then these caps will bleed down, and they will bleed down through your LEDs, and the LEDs will stay on for quite a while. And with quite a while, I mean like, I don't know, 20 seconds or so before they slowly dim down. And the larger these caps are, obviously, the bigger this delay is going to be. So that's a bit annoying if you turn off the power and your LEDs don't go out immediately. If it is like in a period of 1 or 2 seconds, this can be a nice effect. But if it takes 20 seconds for them to go out, it's not really what you want. So what you can do is you can put a bleed resistor across the LEDs. But the problem with that is that these caps are quite big, and you will need a relatively low value of a bleed down resistor to make a difference here. And that'll put a load on your power supply, because it'll be there indefinitely. So it will generate unnecessary heat, it will generate unnecessary power consumption, it will put a load on the power supply for your phono stage and your preamp, which is maybe something that you don't want. It's also, the amp is not designed to have a high load on this type of power supply, on this regulated power supply. So it's not ideal. Another way to avoid this is to use a relay, so that when you switch off the power, that the relay deactivates your LEDs, but then you're getting a bit ridiculous in the amount of components that you need just to switch these LEDs. You can do it that way, but it's also, it's maybe overly complicated. So I didn't go that route. The second option is to take the original winding for the bulbs. So you see here we have the 3 bulbs, the original ones, and they are marked 6.3 volt, 80 milliamp. And you see they have their own winding to power the bulbs. So I used this voltage from this winding because you see it's not affected by the capacitors. So if you turn off the power, immediately your LEDs go out. The thing is, obviously, this is AC, so you need to rectify it. But yeah, to me, that's not a big deal, adding a small rectifier in there. So that's what I did. I added a bridge rectifier here and then put the LEDs on the rectified voltage. Let me show you how I actually did it in the chassis here. So this is what I came up with. These wires over here, these yellow and red wires, are the original wiring for the bulbs. So you had 3 pairs of yellow and red wires with the 6.3 volts AC. 2 of those I just cut the bulbs out because these were these type of bulbs. Let me just quickly show you. See, so it's these types of bulbs that are just shrinked on the wiring. 3 of those. So I cut all 3 out, and 2 pairs of wires, they were just, I just took them out of circuit basically. And the other pair, I put a connector on those, and I created my own little PCB. Maybe it's better if I show you like this. Let me just put it a bit. Yeah, I think that's a bit better. So you have the AC, the 6.3 AC volt coming in over there. And then we have the bridge rectifier. I have a smoothing capacitor because you really don't want any ripple on your LEDs. This is a 47 microfarad at 25 volts. I have it, you can see it under the tie wrap, but there is a diode, and that diode is is in series with the plus, with the positive voltage to eliminate any backwards voltage, because LEDs don't really like being powered on backwards. Then there is the dropping resistor, and the dropping resistor is in series with the potentiometer. And that way I can adjust the intensity of the LEDs. So the potentiometer and the dropping resistor together, they limit the current for the LEDs. And this connector goes to the 3 LEDs which are in parallel. 10 and so brown, black, brown, indeed that's 100. So I put 100 ohm in there. Then I put a 1K pot in series, so I can go anywhere from 100 ohm to 1100 ohms. So that allows me to adjust the brightness of these LEDs pretty well. And then the LEDs themselves, see, so I put some new grommets in here and I glued the LEDs in there. I had to cut off a bit of the rim of the LEDs to have them fit better in there. But these are now very well sealed in here, and they are, as you see, wired in parallel. And the nice thing about this setup, like I said, is that I can adjust the brightness, because it's always a bit dangerous if you put LEDs in here and they are too bright. It's super annoying when you have an amp in your living room in the evening or in the dark, and these LEDs, they are just super bright. It's really annoying. So it's also difficult to adjust this on a workbench. I think I have adjusted more or less to 7.5 milliamps currently. So in any ways, it's always a good idea to run LEDs quite low, because that'll increase their lifespan and it will radically reduce their power consumption. And they also don't generate any heat like that. And anyways, these VU meters, they really need to have a soft light. So yeah, don't run them at 20 milliamps. It's ridiculous. The only thing is that I put in here a 20 turn, or it's a 25 turn pot. That's a bit exaggerated for this application, and it's a bit annoying even. So I would, yeah, a 10-turn pot would have been better, or maybe even a 1-turn pot. But I can show you that it definitely works. I just need to make sure that I do, yeah, make a lot of turns at a decent speed. Otherwise, you won't be able to see the difference. But see, it's going down. It's dimming down quite well, like this. Now, the thing is, the dimmer your displays will be, let me turn off these lights here. That is turning the light on. Let me turn this off. Now, the dimmer that your display will be, the more that you will get these hotspots of the LEDs, and the less spreading out of the light there will be. So you do want to have a decent amount of light, but not enough that it's too bright. So let me turn it up again, and you will see that it will get brighter. If I can leave my screwdriver on the potentiometer, that would be nice. It's a bit awkward with my left hand here to do this. But yeah, you see that the intensity of the displays is increasing quite well here. And especially towards the end of the range, it's getting very bright. It's way too bright, this. And yeah, now the flickering is because my camera is... the shutter speed of my camera, there is no flickering at all here in real life. So yeah. See, but now it's way too bright. So I'm just gonna tune it down a bit again. Yeah, I think this is more or less okay. All right. So that's a big task done. I actually had quite a bit of work doing this. Took me quite a bit of time to get this board in there and to get all the LEDs, especially wiring up the LEDs in there. The 3 LEDs in parallel, that was quite a bit of work. And then making the board. But I'm actually quite happy with the results. Sometimes you see LEDs which are, yeah, really don't fit this vintage equipment. But here, I think it's quite okay. It's maybe a bit yellowish, but I'd rather have that than it be too white or too cold. So yeah, quite happy. Now, another cool thing about this setup is, since it's a 100 ohm resistor in there, you can simply measure the voltage drop across the resistor and you get a nice indication of the current going through the LEDs. So this is now, as you see, 7.5 milliamp, because 0.7 divided by 100 ohms is 7.5 milliamps. Okay, so here we have the casualty list, and it's quite a bit more extensive as I originally thought it was going to be. I just thought it was going to be a quick fix of just swapping some transistors in one channel. Turned out to be a lot more than that. So we have here the small signal transistors. These two, those are the differential pair of the left channel. These are still okay, but they went, yeah, out of alignment with each other. So I replaced those to get less DC offset on the left channel. These ones are all blown. Some because of me, some because of the event that happened with the fake transistor in the last video, and some were already blown before I got the amp. This is the most spectacular one. That's the one which blew its top off in the last video. I even found its top on the other side of the room just by coincidence. It's quite funny. These are the drivers. The top 3 here are the original ones. They are still good, but I replaced them anyway because I wanted to have matching drivers on both channels, and one of the original ones was missing, so I replaced those with the Toshibas. Those are these kinds, and these three, they are blown. I blew them along the way, either because of my own mishaps or because of this catastrophic event of the last video. That's the resistor on the right channel towards the headphone jack, which was overheated and out of value. That's the blown resistor due to the casualty of last video. These are the both bias pots. Those are the diodes of the left channel. These were also way gone. The three bulbs, some tantalums. A couple of those were quite bad, so I replaced all tantalums in the amp. The outputs, this is an original one that I blew by just being stupid, and these are the ones that blew because of the fact that this is a fake one. And then all capacitors that I replaced. Now, most of these were still okay. Some were a bit out of spec, and I would have replaced those anyway, but I decided to just go in and replace all the capacitors. Most of these are only 10% out of spec, so they would have still worked fine if I didn't change them. But hey, I decided to, since I'm spending so much time on this amp, I decided to replace all of these. And then the grommets for the bulbs. So that's quite the casualty list for this amp. I put the cover plate back on, as you can see. I cleaned it up. It was quite a challenge to get it back on, because I think this amp was handled quite roughly in its life, or it must have taken a hit, and the chassis is a bit warped. Yeah, you can see here that there is a gap between the side panel and the top panel. So everything didn't really fit well. It was, took a bit of time to get it back together, but we're here now, and I think I'm done with this amp, finally. Okay, so I think we are done, finally. It was a bigger challenge than I expected it would be. It took a longer time than I expected. I originally thought it's going to be like one video of diagnostics, checking which transistors I need and ordering them, and then a second video of the repair, but it turned out to be a bit more interesting. Well, at least we've all seen a nice explosion, right? So if you have followed along this project, then I'd like to thank you for following along. I had a lot of frustration, but in the end, you see, you get the result you like, and then it's still okay. It was really still worth it going through, because I do think that it's a nice amp. What I'm going to do now is I'm going to set this up, I think, in my living room. I'm going to use it for a couple of weeks on a daily basis and see if there's nothing wrong with it, if it doesn't start acting up. And then if there is still something that I need to do on this amp, then I'll post an update video. But normally, if everything goes well, then you won't see it again on the channel. The only thing that I'm still thinking about doing is adding a speaker protect circuit. You can easily buy these modules online, which you can put between the outputs, the output transistors and the speaker plugs, so that when you get a significant amount of DC offset, that it automatically shuts off the speakers so that you don't burn your speakers. That might be a nice addition to this amp. It could be that I still do that in the future, but if I do such a thing, then you might see this amp again on the workbench, but hey, who knows. Anyway, I'd like to thank you for watching, and I hope I'll see you in the next video. Take care. Bye-bye.